Okay, we are going to take a look at 2014 number 4, part C and D. In part C, they tell you at time t equal 2, the train's A's position is at 300 meters east of origin station. You got to love this origin station. That is basically means it is 300 meters to the right of 0. The train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from origin station at time t equal 12. And then we're going to use a trapezoid sum with 3 subintervals and approximate its position at time t equal 12. So first of all, an expression. To write an expression at t equal 12, first of all, at any time t, s of t is 300 plus the integral from 2 to t of v a sub x, or v sub a of x dx. And then at 12, s of 12 will be 300 plus the integral from 2 to 12, plugging a 12 in for t, of va of t dt. Okay? I had to use x's here because we put a t there, but once I put in the number, I just went back to t's. So let's figure out what this integral value is, all right? What's the integral from 2 to 12 of the velocity v sub a of t dt? So we're going to use the trapezoid rule. So when we go, the first interval is going to be, we're doing this from 2 to 5, okay? So 2 to 5 is my first interval, and that means the delta x or delta t is 3. And trapezoid rule is 1/2 the height, and so the height of my trapezoid will be 3. So it's 3 over 2, and then the 2 bases will be the heights of the function. So that'll be 100 for the one on the left and 40 for the one on the right. And so it'll be 100 plus 40. Then you got 3 between 5 and 8. So your delta x, or the height of the trapezoid, will be 3 there also. And then half of that's 3 halves. Your left side will be 40, and the right side will be negative 120 for the 2 bases. So 40 plus negative 120. And then the last one goes from 8 to 12. So that delta x is going to be 4, or your height of the trapezoid is 4. And so that's going to be 4 over 2. And then your bases, which run vertical, one base is negative 120, the other base is negative 150, and I add those up. And so when you do all the calculations, it comes out to be negative 450. And so then you got to go back and add your 300 plus your negative 450 is your displacement. This is the position at time t equal 2, which is the initial condition they gave you, because we're doing it from 2 to 5, or what is it? Yeah, 2 to 8, sorry. And so we go 300 plus negative 450 equals negative 150, okay? 1 point for the position expression, so this right here would give you a point, all right? And then 1 point for the trapezoidal sum, which means you showed this work right here, and 1 point for the position answer, which is negative 150. And you do need to state, that should be, I should have meters there. And you state the position of train A at t equal 12 minutes is 150 meters west of origin station. That statement needs to be there. You can't just get an answer, a number answer. You have to say what's going on. You have to let them know you understand what you're doing. All right, now let's look at part D. There's a second train, train B. It travels north from origin station. At time t, the velocity of the train B is given by this equation right here. And at time t equal 2, the train is 400 meters north of the station. We're supposed to find the rate in meters per minute at which the distance between train A and train B is changing. So here's a little picture of the situation. Train A is east of origin station. Train B is north of origin station. Their distances, A is 300 meters to the east. They told you that in part C right there. And then train B is 400 meters north, which they told you here in part D. And then we are trying to find the rate at which their distance between them is changing as they're moving. So we want we want to try to find dz dt. is what we're trying to find. So you have x, y, and z, a right triangle. We're going to write the relationship between x, y, and z. This is related rates. The relationships are x squared plus y squared equals z squared is the relationship between the three variables. Again, we're trying to find dz dt, so we're going to do implicit differentiation, and you get 2x dx dt plus 2y dy dt plus equals 2z dz dt. We can multiply both sides by half and get rid of the 2's. And now it's time to start plugging everything in that we know. We know that x is 300 and y is 400. And we can figure out z because it's a right triangle. So 3, 4, 5 triangle means that z would be 500, or you could use a Pythagorean theorem. The velocities, we need to figure out what the velocity of train B is at that time. And they tell you an equation right here for velocity. And so I'm just going to plug a 2 in to figure out what the velocity is at time 2. I did that right here. I plugged a 2 in and got 2 squared is 4 times negative 5 is negative 20. 60 times 2 is 120. And we've got 25 added on as well from the equation. And we get 125 for the velocity of train B at time t equal 2. So now we plug all the stuff we know in. X is 300. dx dt is 100. And how in the world did we know that? Where'd that come from? Right here, folks. At time t equals 2, the velocity of train A is 100. You had to go back to the chart. And then y is 400. That's the distance from origin station. And 125 is its velocity, which we just figured out here. We know that z is 500, and we're trying to find dz dt. Do a little algebra, and your work will come out that dz dt is 160 meters per minute. You get 2 points for doing the implicit differentiation correct of this distance relationship, and then you get 1 point for your answer.